Good viewers, welcome to Correct Tutorial class. Today we have derived quantities and units. Remember, in our former video, we have explained the fundamental quantities and units, but today this is what we want to check now, the derived quantities and units. Now, what is derived quantities and units? Derived quantities and units are quantities that are obtained from some simple combinations of fundamental quantities and units. And at the same time, they are dependent of fundamental quantities and units. That's all. Now, today, we have a lot of derived quantities, plenty. So, but today we want to check this particular derived quantities. The first one, area, volume, density, velocity, speed, acceleration, force, energy or work or torque, power, momentum, impulse, pressure, and others. We still have a lot of stuff more than that, more than this. But this is the formula. Because of time, this is the formula of area, length times breadth, as we all know. So the volume is length times breadth times height. So the density is mass over volume, while the velocity displaces over time, the speed is the distance over time, the acceleration for velocity over time, force is mass times acceleration due to gravity, while the energy is force times distance, the power is work over time, and on like that. Momentum, mass over velocity. So what is their dimension? This is what we are going. This place. That is where we are going now. What is the dimension of area? The formula is length times breadth. Remember, from the fundamental quantities, we have three major quantities. That is what we are going to use to derive all this, to find the dimension of all this. So the first one is length, mass, and time. Length, mass, and time. This one is under fundamental quantities. So that's what we are going to use here. So if you say length or breadth or height or displacement or distance, we are going to represent it as L, capital L. So if you say mass, you change it, you use capital M. And if you say time there, you change to a T. So that one don't change. That is the fundamental. They don't change. Now, we have the area, length times breadth. Remember, the length multiplied by the breadth. The breadth, the fundamental, the dimension for breadth is also length, LL. So now we have L here, L here. So remember the indices, L multiplied by L. So that is L squared. But since we have LL that is common, you pick one L. So we have one here, one here. These times we change to plus. So 1 plus 1, that is 2. That is L squared. So the dimension for area is L squared. The volume, length times breadth times height. The dimension for length is length. The dimension for breadth is also L multiplied by L. The dimension for height is still L, length, L. So we have one L, one L, one L. So L, they are common L. So we had this 1, 1, 1 together. We have L raised to power 3. So that is the volume, L raised to power 3. That's for density, mass over volume. We have mass. The dimension for mass is M, while the dimension for volume, this L raised to power 3 divided by, volume, the density is mass over volume. So mass divided by the volume the dimension is M divided by L raised to power 3. So if you want to make this one index form, it will now be M L raised to power minus 3. By the time this 3 to come up here is going to bring minus because of this divided. Because of this, they're divided in indices. In the index form, is changed to minus. That's all. That's why we have this ml raised to power 3. So we have ml raised to power minus 3. So that is for density. Now the next one is velocity. Velocity is displacement over time. So displacement, the dimension for displacement is L divided by time. Time, is T. So this one in index form, L divided by T is L raised to power minus 1. Simple as that. So the velocity is L raised to power minus 1. That's all. The speed, the dimension for distance is L. This L, the dimension for time is TT. That one don't change. So it's still L raised to power minus 1. So the acceleration is velocity, change in velocity over time. The velocity, our velocity is L raised to power minus 1. Our velocity here, velocity is L raised to power minus 1. So divided by time. So divided by time. The dimension for time is still time. So what we are going to do now, since we have, this is this is L. So since we have L raised to power minus 1 up, and we have, T raised to power minus 1 up, we have T raised to power 1 down. So you want to take this, because T is common, T. So I want to transfer, minus 1 is there already, as in, this is L. This is T and T. Take one T. So minus 1, that is up already, minus 1. This is 1, the downstairs. So you want to take this 1 to come up, but this divider is going to be affected with the divider. So the divider will tend to minus. So you write the minus, and this 1 will come. So finally we have LT raised to minus 2. So LT raised to minus 2, that is for acceleration. LT raised to minus 2. So that is that. So for these force is mass times acceleration. Force is mass, acceleration is LT raised to minus 2 multiplied by LT raised to minus 2. So if we match this one together, we have the force, the MLT raised to minus 2. Shikena, simple. The energy, the formula for energy and work and torque is force times distance. It's still the same thing. Force times distance, as you can see here, force times this. The dimension for force, the dimension for force is here. Force MLT raised to minus 2. So MLT raised to minus 2 multiplied by the dimension for distance is L. The dimension for distance is L. So we have 1 here, 1 here. If we multiply it together, 1 plus 1 there, we have 2. So we have ML2 T raised to minus 2. So for energy is ML raised to 2 T raised to minus 2. That is for energy. Now for power, power is work over time. We have work divided by time. This is the work. Work is still the same thing as energy, and as well as the torque, first as distance. So work is ML raised to 2 raised to minus 2 divided by time, T. So this one now we have work, ML2 raised to minus 2. So we have 1T downstairs. So by the time this 1T comes up, to come and join this one will become minus 3. So power is ML2 raised to T raised to minus 3. That's all. So for momentum, mass, and velocity, remember that momentum is mass times velocity, mass times velocity. Mass is M. The velocity is, this is the velocity, LT raised to 1, LT raised to minus 1. So if we merge it together, we have mass times velocity, LT raised to minus 1, minus 1. So that's for velocity. Impulse, force times time. The dimension for momentum and impulse are the same thing. I will show you now how, like this. The impulse formula is force times time. Force times time. So what is the dimension for force? We know force is mass times acceleration due to gravity. So we have the force is MLT raised to minus 2 times time. Times time. So if we take this time to multiply this, because 1 is here. So now this T, the force is here, the force. This is the force. MLT raised to multiplied by T. So we have 1 here. Remember that this time we change to plus. So So we have minus 2 plus 1 for these two to match together. So we have mlt raised to minus 1. So that is the reason why the impulse is mlt raised to minus 1. As you can see, because we have plus there, so this times will change to plus, so we have minus 2 plus 1 because of the t and t. Simple. This one is just indices method approach. Now, pressure is force over area. Force divided by area. Force is m lt raised to minus 2 divided by area is length times length, or length times breadth. That is L square. As this L square, L square. Remember, we have one L on top. One L is on top here. So we have 2 downstairs. So it means 1 minus 2. That is the many. So 1 minus 2 is minus 1. So we have M, which is M L raised to minus 1, T raised to minus 2. That is the dimension for pressure. M L raised to minus 1, T raised to minus 2. Simple as that. The frequency is the number of oscillation divided by time. You know, frequency formula is is 1 over T. 1 over T. The frequency, number of oscillation, F is equal to 1 over T, the period T. So time is time. So the dimension for this one is nothing. In index form, this 1 divided by, it means T raised to minus 1. 1 divided by T, that is the meaning, it means T raised to minus 1. Because in indices, this minus, it means 1 divided by. So it remains T raised to 1. If you now pull that one downstairs, here we have T raised to 1. Simple as. So this 1 divided by T raised to 1 is still the same thing as 1 over T. So the dimension for frequency is T raised to minus 1. This T raised to minus 1. The final one here, we have mass flow rate. The mass flow rate is mass over time. Mass over time. The dimension for mass is m. The dimension for time is t. This is t raised to minus 1. That's all. That's all. Very simple. And there's something common here. The speed, velocity and speed, they have the same dimension, and at the same time the momentum and impulse, they have the same dimension. Just take notes. Which one again? They have the same dimension. That's all as far as this video is concerned. That's all. And remember that torque, energy, and as well as the work, they have the same dimension. This is ml raised to 2, T raised to minus 2. That's all. Now I want you to like, comment, and as well as share it to your friends so that they can benefit from it. And at the same time, I'm going to give you just a question. I want you to give me the dimension for stress. No, don't give me the dimension for stress. Give me the dimension for strain. Strain. And the dimension of refractive index. Refractive index. So I want you to put that particular stuff in comment section. So if you have any question, you are free to ask, and ask. Definitely I will answer that particular question based on this. So we take it one after the other. Thank you very much.